This is a second example of me applying Gaussian elimination. So what do we have here is a system of three unknowns, two equations. So geometrically what's going on, we've got two planes. They're non-parallel. So they will intersect somewhere. So we're going to be finding for a solution set where those two planes intersect. We should expect to have a line. And if there's a line, it's written in the vector equation of a line, right? Will be x, y, z is equal to some point plus a multiple of a vector that points in the direction of a line. But in particular, we should be expecting to have a single parameter. So let's see if we see this happening when we cover the solution set. So I'm going to write down the augmented matrix of my linear system. First step is to identify the leftmost non-zero column. It's here. On the top, I want to have a leading one, so I want to have a non-zero in order to be able to divide by whatever number is there to make it into a leading one. So I don't have to interchange rows here since I already have 2 that's a non-zero. So I will divide row 1 by 2 to make it into a leading one. Like that. Notice I'm always writing rows that refer to the rows of the previous matrix. Okay. Row 2 isn't changing. After that, I want below the leading one to introduce a 0. So what I need to do is subtract a multiple of the row that has a leading one from that row. So I'm going to subtract 4 times row 1. This becomes a 0, and after that, if I just keep on going, I'll get minus 3, 3 minus 2 here. And what's next? Well, after that, I will hide that row because I'm done with it. And then I look at the remaining submatrix, which is just that line. That's the remaining submatrix. And I repeat. So I identify the leftmost non-zero column. So it's this one, it's the second one. I don't need to interchange rows, right? And I want to make this minus 3 into a leading one. So I will multiply row 2 by minus a third. I just recopy row 1. It's not changing. This becomes 1, minus 1, and 2/3. And I'm done. Okay, so my matrix now is in row echelon form. Look at the leading ones. They appear diagonally. Below them, you have zeros. And there are no rows of zeros at the bottom of the matrix right now. How do I recover my solution set? Well, let me rewrite the matrix here. I will identify, so there are what x, y, z are my variables. So x, y, z. I can identify what my leading variables are. That's easy to obtain. I just look at the columns with a leading one, and the corresponding leading variables are there, x, y, and by default the free variable, the one that can be assigned a parameter. So technically I could have more than one, but here I just have one free variable. It's z. So I will just have one parameter, and that's what I was expecting. Remember, one parameter, because I'm expecting to get a line for my solution set. So I will start my solution like this. You always assign your parameters to your free variables first, and then you solve backwards your system to get the other expressions for the leading variables. So y. So I'm looking at the last equation. Right, it reads y minus z equals 2/3. Now I've got to solve for y, so I'm going to get 2/3 plus z, and now I replace z by t, and that's y. And for x, the first equation reads x plus a half of y minus 1/2 of z equals 1/2. So I solve for x, I get 1/2 minus a half of y plus 1/2 of z, and then replacing y by 2/3 plus t, and replacing z by t. What do I get? I get 1/3 here minus a half of t plus a half of t. Oh, it's kind of interesting because your last two terms just cancel out. Technically, I could have been left out with the parameter t and the expression for x, but I won't. I'll just have 1/2 minus 1/3, that's 1/6. And so finally, my solution set is xyz is equal to 1/6, that's x, y is 2/3 plus t, and z is t, where t is some real number. But of course, I like to split it so that I can more easily interpret what kind of solution set I have. And if I do this, I recognize that this is of the form P0 plus TV. So as expected, this is the equation. So the geometrical interpretation here, it's a line passing through P, which is 1/6, 2/3, 0, if you want P0, and parallel, or pointing in the direction of, parallel to the vector V, which is 0, 1, 1. So that's, if you're asked to give a geometrical description, or how do I spell this? So sometimes I'll write a geometrical interpretation. That's what I want. Okay, and I want something specific. I want something more than it's a line. I always get that from students. It's a line. Well, what kind of line? It's a line passing through this point and pointing in the direction of this vector.